All right, so hello everyone. Thank you for joining us today for this webinar. Today, we'll be taking a look at building distributed applications with HarperDB on Ametnes Cloud. My name is Michael King, and I'll be your host today. I've got two great hosts with me today, Jackson from HarperDB and Michael from Ametnes. So, Jackson, could you go ahead and give us an introduction of yourself?
Sure. My name is Jackson Rep. I'm the field CTO for HarperDB. I am a father to two daughters and a partially reformed or recovering developer. And my mission in life is to make really, really complex processes and technologies look simple and be usable. That's my passion in life, is to reduce complexity so that we can get outside and maybe touch grass.
Yeah, that would be great. Yeah, for sure. Especially when you live in Colorado, which is just such a beautiful state. I live in Louisiana, kind of flat. There's not quite so many mountains, so I'm a little jealous of you there for sure. So,
but
awesome.
you have the drive-through hurricane restaurants, so that's good.
Yeah, exactly. So, and I don't know, you can also get, alcohol to go, which I think is a little different for some states, but yeah.
Sure.
But anyways, so the other host I have with me today is Michael. So could you go ahead and give us an introduction of yourself?
Hi, thank you. Can you hear me okay?
Sounds great.
Yeah, good. So my name is Michael. I am the founder and CEO of Ametnes. I have been working as an engineer sort of across the IT space. I've worked in various roles, starting as a software engineer, infrastructure engineer, most recently as a DevOps engineer. And some of the issues that I faced and encountered working on those roles led me to start up Ametnes, which we are going to dive deep with Michael as well. So yeah, that's me. So I'm a father of 5 children, and I sort of swing between London and the US every now and again. So yeah.
Nice. Yeah, it kind of sounds like me, except instead of kids, it's cats. I don't know, me and my fiance, we have a couple of cats. So it's no kids, I guess, luckily for me. I don't know, I guess it depends how you look at it, really. But anyways, I guess not to leave myself out of the picture. So I've been a full stack engineer for about 10 years. I've had kind of the fun and responsibility of working on everything kind of from the front end to the back end. And I've always really loved systems and databases and kind of everything in between, basically. So right now I work in the developer relations space, so I get to deliver a lot of content like this webinar today to developers and engineers kind of like yourself, perhaps. So with all of the introductions out of the way, we can go ahead and cover what we'll be talking about today. So first, we'll get some more information about HarperDB from Jackson, and then we'll also get a little bit more information about Ametnes Cloud from Michael. Then what we'll do is we'll jump right into the details and actually do a live demo launching a HarperDB instance in Ametnes Cloud. Then we'll jump over to HarperDB Studio and then actually go through importing some data, setting up some tables, and then we'll show some different queries that you can do and how powerful the engine really is through some of its robust role and permission systems, and even a really cool chart feature that's included as well. So before we get into the introductions, we do want to cover a few things. So we will be recording the webinar. You can expect the recording link to be emailed to you afterwards. And then we'll also be saving the Q&A for near the end of the webinar, but you can always submit all of your questions during the webinar itself, and we can get to them during the webinar if we have some time, or near the end as well. So with all of that out of the way, Jackson, I'd like to turn it over to you so you can give us some more information on HarperDB. So yeah, feel free. I'm going to go ahead and stop sharing so that you can share your slides. Oh, you're muted, sorry.
There we go. You feel like you're looking at globally distributed application platform slide?
Looks good.
Outstanding. All right, let me move this out of.
I think Jackson, you're still muted.
No, he's good. I can hear
No,
him.
I'm good. I couldn't. I couldn't see everything I needed to say. So globally distributed application platform, HarperDB. HarperDB is a globally distributed application platform. And we were founded in 2017. We just celebrated our 6th anniversary. We have 100,000 plus deployments and a robust Slack community of developers and business owners and technology leaders that all help contribute and make this product as cool as can possibly be. We have some big logos, large network providers that see the value in distributing data to the edge along with all the other things that they put out at the edge in order to increase performance and potentially for a lot of applications, lower costs. So HarperDB, despite the DB right there in the name, and that's where we started out, is now actually a comprehensive platform, including a database, an application tier where you can run business logic, create API endpoints, have long-running processes like machine learning, generate machine learning models, or collect sensor data. And then finally, distribution. We are a distributed database by default. So what that means is if you want more capacity, rather than raising the amount of resources dedicated to the server upon which that node of HarperDB runs, you can simply add more instances of HarperDB and then connect them. And then distribution, by distribution, we mean we can replicate data between those nodes so that any user, no matter where they are, can have a node of HarperDB close to them, which lowers latency, increases performance, and generally delivers a better user experience. So we look at the status quo, how it's always been done up to now. We did a really good job of distributing APIs, right? We have lots of Lambdas, serverless function, EC2 servers that you can spin up all over the globe, from hyperscalers. They all have their VMs you can spin up very close to users. However, those APIs were then asking a database that usually sat in one region, US West 1, and if you were in California when you were making a call to get data, that was a very good user experience. But everywhere else, it tended to not be that great a user experience because the round trip introduced so much latency. We thought that was not a scalable model because if you continue to add resources to that monolithic database, you encounter an exponential cost model wherein 16 gigs of RAM is always more than twice as much as 8 gigs of RAM. And when you get up near a terabyte of RAM, it's incredibly expensive to spin up a database that can support that many simultaneous connections. And we believe that the new paradigm is to combine the data and those APIs and the application logic into one package and then distribute that everywhere close to users on a platform much like Ametnes, right? You spin these things up where your users are so that you can deliver them a good user experience. And then HarperDB takes care of the hard work of reconciling transactions across all of those nodes. We have the additional advantage that because the API is right next to the data, there's no additional latency that you normally have going from an API server, that big round trip now doesn't exist because the data is right there. When we look at what our customers ask for and what we try to deliver and what's we think important in a database, especially in modern applications, speed. Obviously, we want to handle as much as we can in terms of transactions for both reads and writes. We want it to be scalable. We want to be able to handle lots of users by adding lots of nodes, and you can add lots of nodes through HarperDB. And depending on the network connections, you can see latency as low as 2 milliseconds. Let's say you've got an on-prem deployment, but standard cloud instances that are closer to users as low as 50 milliseconds, and then replicating that data around the globe as low as 100 milliseconds. So again, we're scalable and still performant. 100 milliseconds is not that much time. And then extensible. We built a feature called custom functions, and Michael will demonstrate that ad nauseum through this series. But what it allows you is basically, instead of just interacting with it as a database, we are, again, that application platform. So you can define your own logic and put that on all of those nodes across your cluster of HarperDB instances. And then finally, flexible. We know that we use pub/sub between nodes of HarperDB in a cluster. And so we also accept that while users may have systems of record in one of the hyperscalers, lots of people are trying to deplatform from those, and we can help you first deliver a great user experience by exploding off of those systems of record, and being closer to users without altering the back office functions that probably talk to those databases and, actually push content out to those users. Eventually, what we found is that customers will, after they've solved the user experience problem by lowering that latency and being closer, then they start to point their back office functions at HarperDB as well, eventually extricating themselves from that cloud lock-in. I have just a few case studies that sort of cover what we do. We did a gaming POC for one of the largest gaming networks. We were able to lower latency by 90%, and that resulted in a 90% reduction in infrastructure cost. We did the same thing for a streaming media company. If you've ever been streaming something and then you go back to that show later and you're 15 minutes behind, and now you have to scrub forward and try to remember like where you were and all that stuff. That's just the lower fidelity of recording where you were is a very real result of too much volume hitting a server and overwhelming it when millions and millions of users are trying to record exactly where they are in a stream. So you lower the fidelity, the rate or frequency at which those user devices call in and say, here's where I am, in order to increase capacity. And we solved that problem for them, dropping latency by 70%, but also, again, reducing infrastructure costs by 70%. And then finally, we worked with a large weather application that probably powers the weather service on your phone. And for them, we created an edge cache, right? So a cache of data closer to the user that can respond in 2 to 4 milliseconds, for cache values, and origin calls that were taking, nearly a quarter of a second were reduced to a fraction of that. And we were able to prove, we can do this at volume, right? Again, if you can serve 100 users with a one node or 100,000 users with one node of HarperDB, and it costs you $200 a month, then you can serve 200,000 users for $400 a month. So it's a very linear cost to capacity ratio. And that's really, when we look at distributed systems and when we look at global user bases, we want to make it easy. So if you have a database and an application stack and a message queue to move things around and all of the hardware, that you have to provision and network stacks and all of those things you have to worry about, there might be upwards of 100 moving parts in one deployment, in one region. Imagine you want to be in 100 locations. Now you've got 10,000 things to worry about. And really what we look for, what we wanted to accomplish, and why we like Ametnes is we make it very, very simple from an application stack perspective to have everything in one place and to rest assured that we will take care of the heavy lifting of moving data between those nodes. And Ametnes then makes it very, very easy to be in those 100 locations. So together, we think it's an optimal product solution that is not only more scalable, more cost effective, but easier. And ultimately, that's what HarperDB is all about, right? Simplicity without sacrifice. All the features you need without any of the traditional, headaches that factor into a total cost of ownership that ultimately a lot of people don't scale past. And that's HarperDB in a nutshell. Thanks very much.
Yeah, awesome. Thank you. Yeah, and like you said, I've personally had the chance to work with HarperDB a bit. I actually have an instance I've deployed internally on my home network that I push a bunch of IoT sensor data to. And I have some custom functions set up where I can send out an email to myself, like if there's an alert or something like that. So I've always found HarperDB kind of works with that because I deployed it one time and that's it. And I always found kind of the simplicity was really nice of it. So, awesome.
Absolutely.
Yeah. So Michael, I'm going to turn it over to you, and we'd all like to now hear more about Ametnes Cloud and some of the different things that it brings to the table and why it's kind of one of the better choices for doing these kind of provider agnostic deployments, kind of like we would like to do with HarperDB, basically.
Lovely. Thank you. Thanks, Michael. And thanks, Jason. That was really good. So let me share my screen now. Okay, let me know if you can see my screen.
Yeah, looks good.
Okay, so let's go to the start. So Ametnes, so we basically are our objective is mainly to help engineers provision and automatically manage a wider selection of cloud-native data services across multiple cloud provider platforms. So this is both in the private and public cloud. And the data services we are talking about here are databases, messaging, caching, machine learning data services, a plethora of them that we will touch on a little bit later. So the benefits of Ametnes is our objective is to have a very wide catalog of data services. And how we achieve this is by focusing on them being cloud native. How that is possible is we focus and purely run on Kubernetes as a platform. And what that means is we're able to run in both private and public clouds, basically on-premise or in managed cloud services such as AWS, Google, or Azure. So what we bring to the table is, so we are agnostic to any cloud. We're agnostic to any data service. So we provide an orchestration platform where you are able to provision data services such as HarperDB, as we'll see in a moment. In addition to that, we provide the managed part of it. We'll provide you with automated upgrades, managed backups, automated certificate rotation. And then the upgrades is quite an interesting feature, because when you run on Kubernetes, you have about 3 or 4 different dimensions you have to look at your management of the service. For example, when you upgrade the Kubernetes version, some APIs do evolve, some APIs get taken out, some change. And that oftentimes, the way you find that happen, that affects you is by your system going down. So even though the cloud provider could, for the most part, take care of upgrading your APIs, it doesn't safeguard you from failure. So you have to be on the lookout when these change. And oftentimes what customers do, they'll pin down and stay on one version, for even 5 years, even when the cloud provider cannot provide any support for it. So we'll take that pain away from you. But also, not just that, when it comes to upgrade of the data service, for example, Harper. So we work with HarperDB, and we've seen that, for example, when you upgrade from 3.3 to 4.0, a few things change, such as the configs, the data locations. There's a lot that goes into upgrading from one version to another. So Ametnes aims to make that seamless for the customer and for the engineer. In addition to that, obviously, we provide that single pane of glass view to all your data services with the way that we've architected our platform. So this is just a brief view of the architecture. It really, so it's just a simple architecture. What you do is you deploy an Ametnes agent that sits in your cluster, your Kubernetes cluster, and that agent talks to our control plane. So whenever you need a data service, you basically talk to our control plane. Our control plane then, so the agent picks up instructions from our control plane, and it fires away and does all the all the provisioning, all the management, all the certificate upgrades, updates, and the service upgrade as well. So this is a bit of a scaled up version of, just to give you a bit of a bigger picture. So you could have potentially you can have a Kubernetes cluster running in your private data center, running on Azure or AWS. It doesn't matter. What we do is we'll take care of the provisioning of the load balancers, all the not the infrastructure networking, but the networking of your services to expose them to the outside world, which is something that, if anybody is familiar in the audience of familiar with provisioning services, you provision the service, but then you have to expose it so you can reach it. What engineers tend to do is you provision the service, and then you have to find a way to reach that service. So it's quite a task that it's enjoyable to do initially, but then as you do it often, it becomes less of an interesting task, and that's where the automation that Ametnes brings to the table. So some of the example use cases that we've seen customers consider are by way of running on Kubernetes. It allows customers to, for example, run on-demand instances for their production workload. Okay, but when it comes to their dev and UAT, they're able to run them on spot instances. This is, for example, in AWS or Azure, but with the same spec. What that gives the customer is, or the engineer, is the ability to cut down costs when they run when they run their data services in the cloud. But further to that, we allow, because of running in Kubernetes, customers are able to fine-grain their instance specs in terms of CPU and memory. So our positioning basically is we work with the vendors such as Harper. What we bring to the table is the fact that Harper as a platform, as a service, now because we're able to provision HarperDB on Ametnes Cloud, all of a sudden you've got any customer that runs Kubernetes and installs the Ametnes Cloud agent has all of a sudden got access to Harper. It doesn't matter whether they're running on the edge or on premise, or in the cloud, AWS, or running in their own private data center. And why that is important is this, that there are parts of the world where, for example, in some parts of the world, AWS and Azure are prevalent, but then other parts of the world, they've got private data centers because they haven't got access to the major cloud providers. So Ametnes makes that really easy. And we've tested, for example, HarperDB. We've tested HarperDB in a very low spec, for example, very low spec machine running a very simple Kubernetes cluster, and it spins up quite nicely. You can scale it out and provision it to run on something like 32 gig or 8 CPUs, and that does work well. So it's got that elasticity that brings, and we work with database vendors to understand their databases. We've worked with HarperDB for the last 6 months, understanding how to tune and get their database well configured. So we automate that piece. And you will see in a moment that on when Michael does the demo, so you'll see that we have access to multiple data services, examples of which I have listed here. So for example, in production, we've got MySQL, Harper, Postgres, Redis, Neo4j, and a few others. But we've got a lot more coming. We've got Open Metadata, Commander ZB, Airflow. So we are positioning ourselves as that platform that helps these data service vendors to scale out and roll out their products a lot quicker. But furthermore, we are actually open to discussions, also suggestions. We've got engineers that are ready to roll out any new data services, and we think we've figured out a way to scale our service by using by the way that we've architected our platform. So we are quite excited about what Ametnes can bring to the table. There's obviously a lot more information you can find on our website. You can try Ametnes. There's a free version that you can try. Contact us for any suggestions, or there's a few demo videos on YouTube, and follow us on Twitter and on our LinkedIn page as well. So thank you for that. Over to you, Michael.
Yeah, awesome. Thank you. And yeah, I know exactly what you're talking about, like fighting with the different APIs, whether it's Google or it's Amazon or it's Azure's. They all kind of have their own little picky way of handling everything. And I know from personal experience, being able to abstract a lot of that configuration and just deploy the service and really get it working is a huge thing that developers and kind of technical engineers really need. So they can actually spend time doing the things they want to do and not configuring a service or a load balancer, right?
Oh, absolutely, Michael. You touched on a very important point. So it's quite interesting that even though you're deploying on the same platform on Google or Amazon, you find that there are some little nuances that you have to deal with. For example, file permissions, the permission of the user that runs, tiny little things that will cause you a bit of a pain and headache when you're deploying the services. That's what Ametnes brings to the table.
Mm-hmm. Okay, awesome. So yeah, so that was a great introduction to HarperDB as well as Ametnes Cloud. So what I'd like to do now is actually move over to the demo, and we'll actually launch an instance live and then add it to HarperDB Studio. So I'm going to go ahead and share my screen again. All right, and over here I have the Ametnes Cloud pulled up, and I have just our services listed here. And to get started, all we really have to configure is our service location first, which I already have configured here for GCP, for example. So I'll go ahead and I'll hop back over to services, and I'll click new service here, and we can get started adding the service from here. So as you saw, we have a whole list of different services that we could launch. It could be HarperDB or MySQL or Postgres, for example. But what we'll do is we'll go ahead and add a HarperDB. We'll call it our webinar instance. And then for the resource kind, we'll just select HarperDB from here. And then for the location, I'm going to pick that pre-configured one that we've already set up here. And then we can go and actually get into some of the actual configuration of the instance itself. For example, the CPU or the memory we could bump up if we would like, and then even increase the storage as well. The only other real bit of configuration as far as like the location that we need is we need to select what our network is going to be. So I'm going to pick this number 10 one here because that's the one I've used before. Then we get into just some of the basic configuration. So we have like our admin password and our admin user. So I'm going to go ahead and put in a password here. And then for our admin user, and then I'll put in the cluster password and our clustered user. And then we don't have to put in anything for the fingerprint or the license. We'll figure that out once we connect it to HarperDB Studio. And from here, we can go ahead and click create. So while this is launching, one of the things that we can do is I've already prepared an instance ahead of time that we can add to our HarperDB Studio account. So one thing that I can do is we can go ahead and open up a new tab to Ametnes Cloud. Oh, I guess I signed out, sorry. But so while that is pending, what I can do is we'll just go back to services, and I've got this demo instance here, and we can click admin to go into the different configuration port. And what this will give us is the resource endpoint and the port that it's selected as well, because one thing that we did not configure earlier, if you noticed, was the different ports that HarperDB is going to be running. So while this loads, we'll go ahead and wait. And one of the things that we can, since this is already launched, is we'll be able to add it directly into HarperDB Studio and kind of get started. Otherwise, we have to wait for it to, provision the instance and things of that nature. So I'll go ahead and scroll down, and down here, we can actually get the resource URL here. So I'll copy it from right here. And then we can see what the port is as well if we would like. So over in HarperDB Studio, I've already logged in and I have my own organization created. So I'll click create new HarperDB instance here. And we want to select a user installed instance since we're not using HarperDB Cloud, although that is always a great alternative as well. But what we get with Ametnes Cloud is really the ability to kind of launch it exactly where we would like and on any provider. So here we can go ahead and name this as we would like. So Ametnes node, for example. And then we just want to put in what our admin username and password was. And then we can put in the host here. And then I'll pop back over and I'll copy the port that it's set up as well and paste that in there. And I'll enable SSL. Then we can head over to the, cannot log into that instance. Let me try again, sorry. Oh, I'm sorry. I've misspelled the username, but there we go. And let's click details, there we go. And let's just proceed forward with a free instance, which will work fine for this test. And I'll confirm the instance details here. And then I'll agree to the HarperDB terms of service. And let's go ahead and click add instance there. And this will add it to our HarperDB instance, our HarperDB Studio account, and list it in our accounts here. There we go. So it'll go ahead and apply the license and get it all set up for us. So that way we don't have to do any of that kind of configuration ourselves. So from here, we can go ahead and click on this and we can see we're dropped into our blank instance that we set up earlier. So from here, one of the things we could do is we could go ahead and set up some of our different schemas, our tables. We could also import some information as well if we desired. So let's go ahead and create our first schema, which we'll just call dev, but this could be anything that you would like it to be. From here, we can then create our tables below. So let's go ahead and create a movies table with the hash attribute of ID. Now, the hash attribute is just the unique identifier for our table. So this would be like your object ID, or I'll just keep it ID in my case here. So from here, we could start, adding records through the HarperDB API, or you could manually load the records yourself. So since I have around 200 records to upload, I'm going to opt to do a CSV import, but you could also always manually import records like this and add them one or more at a time, like so. But I'm going to go ahead and just import the CSV to make it simple. So from here, you can load it via an URL, or you can just drag and drop a file in, which I'll do in this case. So here I just have a bunch of movies, and we can see here, we also get to see how many records it noticed. So we can see 200 records, which is right. That's the number of records that I wanted to import. So I'll go ahead and click insert, and HarperDB will automatically insert these and then generate an ID for us if it needs to as well. So now that we can see that it's finished importing, we can see some of the data, and let's go ahead and familiarize ourselves with it just so that we're kind of aware of it for when we write some queries here in a minute. So if we start on the very left-hand side, we get our ID. So this is our hash attribute. This is just our unique identifier, like our primary key, basically, for the table. The next column I have here is actually the cinematographer, and then the director. And these are important because we'll use these fields to join on a different table later and get some actual really detailed queries out of HarperDB. The next column I have here is called lifetime gross, and this is just how much the movie made during the lifetime of sales. The next field is the rank, and that's where it fell between the rank of 1 to 200 in the highest grossing movies. Then we just have the title and the year that the movie was released. And then finally, we have these two fields which actually weren't present in my data set, but these are fields and attributes that are updated and set for us automatically by HarperDB, which is pretty cool. So this will automatically set the created time and the updated time for us, so we don't have to add any additional logic to our code to update these fields for us. We can also use these fields in any of our queries as well, so it kind of helps us out in the long run. All right, so now that we've kind of got more aware with the data, we can kind of move on to some of the different querying that we can do as well. So what's really neat about HarperDB is we have the ability to go over this data in a SQL format or a NoSql format. I'll start out with the SQL format since that's built here into HarperDB Studio. So all we have to do is go up to the query tab, and we can actually write a SQL query here and perform it on the database. So what I'll go ahead and do is, I know in the list of movies, there was Iron Man. So what I'll do is I'll write a quick SQL query. I'll select star from dev, which was our schema, and then movies, which was our table. And then I'll add a where clause where the title is equal to Iron Man. And I do need to get the case correct there. And we can go ahead and click execute. And there we can see just one movie was returned, and that's because we're matching directly on Iron Man. And we can see what the lifetime gross is, the different, well, where it fell in the rank, which actually isn't as high as I thought it would be, because that was a pretty cool movie. But we can see a lot of the other information. So from here, we could do a lot of other things. We could query on the different fields. We could also do some more advanced SQL operations, because HarperDB, they do publish the feature matrix that is supported with the SQL operations, and there's almost all of them that are supported. There's very minimal ones that aren't. So you can do things like joins and betweens, ends and likes, and basically whatever you really need to do, it can do it. And throughout a lot of my personal projects that I've done with HarperDB, I've never actually ran into a case where I can't do something in SQL, which I thought was really, really neat. So this is a really kind of basic example for SQL queries. One thing that we can do is we can go ahead and take a look at what it would do to what it would take to do a join on some of this data. But to do a join, we're going to need another table. So let's go back over to browse. And what I'll do is I'll add a new table here called directors. And I'll give it the same hash attribute of ID. There we go. And I'm going to import another CSV file to load this. There we go. And we've got 115 records this time. Perfect. So what I have here is I just have some sample data that I've generated for this. So we just have a list of all the directors that were in the movies table. And then we've just generated a birth year for them and then a random number of movies that they've directed. And then as you can see here, we do still get all of the different attributes that HarperDB manages for us, like created time, updated time, and the ID, of course. So now that we have the secondary table in here, we can take a look at one of those joins that we would like to do. So we'll hop back over to the query tab, and here we can go ahead and write another SQL query. So one thing that we can do with this data is we could join on the director's name and get a list of all of the movies, and we can go ahead and populate the director's name, the birth year, and then the number of movies that we have in our data set as well. So this one's a little bit more advanced, but basically we'll do a select for the directors.birth year. And then we're also going to want the directors.num. I could type, there you go, num movies. And then I'm going to want all of the columns from the movie table. So I'll do .star there. Then we'll do our from dev, which was our schema, and movies, which is our main table. I'll then do an inner join on the directors table from here. And then we just need to tell it what field we actually want to join on. So we'll say on movies.director, and that's going to be directors.name, since I have it set as the name attribute over in the directors table. Then finally, all we really need to do from here is just kind of order it by the name. So we'll do order by directors.name. And let's go ahead and make sure I executed that correctly. There we go. So from here, now we can see we've got all of the records, and we also have all of the data from the directors table in addition to the movies table. So we can see we have the birth year, and then we also have the number of movies, and we can see all of the different directors here as well, and all of the movies. So this is a pretty straightforward example, but there's a lot more that you could do here. For example, like enumerating customer orders or sensor data. It's really the sky's the limit, really, in what you can do with SQL. You can do it with HarperDB, which I've always thought added a lot of flexibility to what we can do. All right, so that was a lot about SQL kind of quickly. But one thing that I mentioned earlier is that we can also do this through NoSql as well. So to do that, you can just submit a request to the HarperDB API to do that. To make this easy, I've gone ahead and I've got a request prepared in Postman. And here, what I've done is I've preset this up with some credentials, and I've pointed it at the instance that we're using currently. And then for the body, we just need to send the NoSql request, which is pretty straightforward. So let's just take a look at it real quick. So first, we're going to set the actual operation. This is how HarperDB's API just works in general. You can do all kinds of things. We could even do a SQL query like this, but I'll show that a little bit later when we get into the roles. So the operation here is search by value, and that's because with NoSql, we can do either, we can search by value, we can search by the hash attribute, or we can even match multiple conditions so that we can match multiple where clauses, for example, in a NoSql format. So I've got search by value here, since that's what I'd like to do here. The next thing we're going to lay out is our schema, which is going to be dev in our case. Then we've got our table, which is movies. And then we need to tell it what attribute do we actually want to search through, which is going to be title, which is the movie title in our case here. Then we just need to tell it what value we want to actually search for. And what I've done here is I've done a wildcard search for Avengers, because I'd like to get all of the different Avengers movies that are in the database. Then finally, the last thing that we'll need to do is tell it what attributes we actually want to fetch. So alternatively, you could pass just the title here if you wanted to just get the movie titles. But what I've done here is I've specified a wildcard, so we'll actually get all of the attributes back. So what I'll do is I'll go ahead and click send, and I'll expand this up here. And we can see that we get an array response with all the different movies that it matched. So we can see it matched Age of Ultron, Endgame, Infinity War, and then just the Avengers movie itself. So pretty awesome. So like I said earlier, we could also do different conditions with this. So if we, for example, only wanted the different Avengers movies directed by a specific director, we could do that in this case. So what I've done here is I've also prepared another NoSql query, because as I mentioned, we could do conditions as well. So let's go over this query real quick that we're sending to HarperDB. So again, we're setting our operation, because before we searched by value. This time we're doing search by conditions, and that's because we want to match multiple where clauses. Much to the same of the last query, we're going to pass the schema and the table, as well as the get attributes. Where this one differs a little bit is that we also get the operator field. And this is where we can specify and or a or clause for our different conditions if we wanted them to work in a specific way, for example. Then finally, we just have our conditions itself, which is an array of different objects that we set up in the same manner as we did previously. We'll tell it which attribute we would like to search through, which is in this case, director. Then we just need to tell it the kind of search types. So this could be equals, greater than, less than, and things of that nature, basically. Then we just need to tell it the value that we actually want to search by, which is going to be Anthony Russo in this case. Then we move on to my secondary condition, which I have set up over the lifetime gross, which is just how much money the movie has made in total. And what I'm doing here is I'm looking for any of his movies that have a lifetime gross of greater than $1 billion. So here I can be very specific with my query and get the exact records that I would want without having to do any additional formatting or write any additional code as well. So I'll go ahead and click send, and I'll go ahead and expand the output here, and we can get all of those responses here. Awesome. So it looks like he's done quite a few that have cleared over $1 billion. So must be nice. So, so that is really kind of shows how powerful the NoSql search is as well. So kind of whatever we can really do, we kind of have the ability to do that with HarperDB, which is really, really awesome. So that was a quick look at SQL and NoSql queries with HarperDB. There's a few other features that I'd really like to show off. So what I'll do is we can go ahead and minimize Postman here. And I'm still here in HarperDB Studio on that instance. And there's a few other tabs I'd like to look at here. The first one being roles. Because if you think about it, now we have all of our data in this database. We can do all of our queries to obtain it. But I know the next question that I initially had was, okay, now how do I secure access to all this data that I now have in this database? So that's where the role feature of HarperDB really comes into play, because we can create roles with extremely specific permissions on schema tables. And what I thought was really neat was even the individual attributes within the table. So essentially, if we had some kind of secret sauce data inside our database, like for example, the lifetime gross attribute, we could prevent this attribute from ever being returned in our database calls, guaranteeing it never gets exposed to any of our employees or even potentially to customers if it's business data in this case. So let's take a look at what it would take to make a custom role. So by default, there are a few standard roles that HarperDB includes. We've got our super user and our cluster user. So we'll be going over the clustering in a later webinar, but basically that one is just used to connect and transfer the data. Then we have our standard roles, and this is where we'll actually create our new role here. So what we'll do is we can just call it test role, for example, and click the add icon. And over on the right-hand side, we get the table and attribute configuration. So from here, we could edit the read, insert, update, or delete permissions on a table-by-table basis and a schema-by-schema basis as well. So by default, the attributes aren't shown, but you can actually toggle the attributes up here with this switch here. And this will show us all of the different attributes that are set up within the tables. And here's how we can then really lock down the permissions if we would like. So by default, when you create a role in HarperDB, it's all set to false. So let's go ahead and fix that real quick, because at the very least, we want to be able to read these records. So what I'll do is I'll spell true correctly, and then I'm going to copy this to all of the different attributes so that we can get them returned from the start. Awesome. And then we can go ahead and do it for these as well, for the movies table, because we only did it for the directors so far. And what I'll do is I'll leave the lifetime gross attribute as false, and we'll actually see if we can get that attribute returned in one of our queries. So we'll go ahead and set the rank to true, the title, the year. And I think that's all good. Let me just double check my work here. Looks good. And then we need to set this to be read to be true as well. All right, cool. So now we have our permissions set up to where we can only read these tables, and we can only read the certain attributes that we've set up. So I'll go ahead and click update role permissions, and this will just do a quick validation and make sure that everything's set up correctly. And that looks good. So now that we have this role, we could attach this role to any number of service accounts or actual individual user accounts that we would like. So that way we don't have to set these permissions 500 times if we've got 500 users. We only have to do it once, and then we can just pass it along, basically. So to do that, let's head over to the Users tab, and I'll go ahead and create an account here. So I'll call this one Test User, and then I'm going to give it a predetermined password that I've set up. And then from this drop down, we can click our test role here and go ahead and click Add. So now that we've added this, we can then use this authentication and these credentials to make requests to the API. So I'll open up Postman here. And what I've done is I already have the authorization set up for our test user here that I set up because I used some predetermined credentials. And for the request body, you can see how I mentioned earlier, we could also do a SQL operation in the same manner to the API. And that's how we can do it in this case. So let's go ahead and run this query. And you can see that I'm just returning one movie from our database. I'll go ahead and click send. And we can see that we have the Doctor Strange movie. But if you remember earlier, when we set up that role, we specifically told it not to include the lifetime gross attribute. If we look through the response here, we'll see that it's actually not there. So what we can do from here is we can show how powerful it really is, because we can go ahead and we can minimize Postman. Let's go back to our role. We can click on our test role, and then I'll scroll down to the lifetime gross field, and I'll go ahead and set this to true. And we'll click save. And then what I'll do is I'll pull Postman back up, and we'll execute the same exact query again on changed, and we'll now see that the lifetime gross field is returned. So this is how we can really kind of prevent a lot of these fields from ever being exposed. If it's business logic, like if we're ranking certain fields or any kind of really minute details that we don't want to get out, we can really lock it down this way. All right, so now that we've kind of experimented with the read access, this really shows how you can set this up, and you could use all of your APIs could use a very tied down role that didn't have delete permissions or didn't have insert permissions, so that you can really be sure your API is as secure as possible. All right, so that is what I had for roles. The next thing that I would like to go over in HarperDB Studio is the charts feature. So this is a really cool feature, and it basically allows us to take one of our queries and see it visually as well, helping illustrate the data and kind of paint a clearer picture for us. And kind of my favorite part about it, kind of much like a lot of the other things with HarperDB, is we don't really have to write any code for it. All we really have to do is just write a bit of SQL, and we can get our chart generated. So to do this and to generate a chart, the first thing we need to do is actually write a SQL query that will base our chart off of. So one of the things that we could do is we had the years that each movie was released, and it might be cool to see how many of these kind of blockbuster movies were released each year throughout the century. So from here, what we can do is we can write select year, and then what I'd like to do is select the count as well. And I'll name this field total just to make it a bit easier. Then what we'll do is we'll select this again from our dev.movie schema and table. And I'm going to group it by year. And that way we can get a count of the number of records per year. And then what I'm going to do is I'm going to order it by year in ascending order. So if we go ahead and click, oops, I made a mistake here. Let's see what I did wrong. Let's see.
I think it's the group. I think you probably need the group by.
Group by, you're right. Yeah. Oops. There you go. Thank you, Michael. And so here we can see all of the different records that are being returned. And while this looks great, this isn't very visually appealing, right? It's just a bunch of text. So let's go ahead and click Create Chart. So HarperDB has many different chart types built in. We can see we have line, bar, area, radar, pie, donut, and even a single value. If we, for example, wanted to get our total sales and just display a dollar amount, we could also do that with the charts, which is pretty cool. So for this, let's do a bar chart, because I think that kind of would work the best. And for our data column, I'm going to select the total. And then for the x-axis, I'm going to select the year. And there we can get a really quick preview of our chart and kind of see what the data looks like. So we can see we have a lot of data kind of from before the year 2000. And honestly, it's not very relevant to me. There's a lot of movies back then I haven't seen. So what I would like to do is see all of the movies that have occurred after the year 1999. So to do this, all we really need to do is just adjust our query. So what we'll do is we'll come down here, we'll just add a where clause where the year is greater than 1999, and we'll click execute. And then if we click create chart again, we'll set it to bar, total, and year. And there we go. We can really see a lot of the more recent information in a very clean manner. So what I'll go ahead and do is I'll name this Blockbuster Years, and we could then add the chart to our HarperDB Studio. Something else cool here is we could also make this chart visible to everyone in my organization. So that way, if all of our developers are really interested in a specific chart, we could add that to our entire organization. And that way, each user doesn't have to go in and manually add the chart and set it up themselves. So if I go ahead and click Add Chart here, it'll add it to our charts, and then we can go over to the charts page, and it will then load it, and we can get the preview here. So that was just kind of one basic chart, but there's a lot of other ones that were available as well, as we saw. So if we go back to the queries, and let's take a look at this query again, and I'll pull it back up. And let's click Create Chart again. And this time I can select a different type of report type. So let's pick donut. And I'm going to pick total and year again. And then what we can see from here is we can see all the different percentages, and we can see the data in different formats if we would like. We could also change it to a pie format and really kind of get it exactly how we would like. So that is basically all of the different charts features that we can do with HarperDB Studio. I personally find it really awesome that this was built in. I thought it was really neat. And I have a chart set up for my IoT project itself to where I can kind of get the last temperature and the last humidity out in my garage, for example. So there's a lot of kind of neat stuff that you can do with the charts in that way as well. So that was the demo. I've kind of thrown a lot at everybody. So what I would like to do is I'd like to hear from Jackson and Michael and get some more information about where users could go to find some more information out about these products. So Jackson, I'll turn it over to you first.
Hi, well, if you want to learn more about HarperDB, you can go to harperdb.io. In the upper right-hand corner, there's a Get Started for Free, at which point you can log into the exact same studio Michael just demonstrated, spin up a free instance, either in the cloud or install locally and register that instance and effectively recreate this entire thing on your own. It should be super easy to use, because again, we focus on simplicity at HarperDB. And I think that's all I have to plug today.
Okay, awesome. Thank you. And Michael, if people wanted to learn more about Ametnes Cloud, where could they go and where could they follow and where could they get all of the good information from?
Yeah, firstly, thank you so much, Michael, for that is such a wonderful demo. So Ametnes Cloud, there's you can go onto our website, and then you should be able to get a free start easily. So some of the data services, most of the data that we currently have are open source, so you don't need a license to spin them up. And then if you for the guides, and we've got some videos on YouTube, and our YouTube channel, you just search for Ametnes in YouTube, you should be able to find us, and you should be able to see some YouTube channels on guiding you on how to set up a location as data service location, and then spin up, for example, HarperDB instance, and something similar, basically similar to what you've done, but only just touching the provisioning of the HarperDB instance. And then you can also follow us on Twitter as well. We do regular updates there, as well as on our LinkedIn page. Just search for Ametnes on either of those platforms, and you should be able to find us. So as I mentioned earlier, if there are any data services in the audience, people in the audience would like us to add on to Ametnes, please send us an email or just reach out on either of those platforms, and we will be happy to consider them.
Okay, awesome. Yeah, thank you all so much. So we have just about 5 minutes left for a little bit of Q&A, and we've got a couple questions that we have ready for both of you. So the first question I have here was for Jackson. Now, I know one thing that I know from some of my personal experience with HarperDB is with the 4.0 release, NATs came into play. So how does that really play in with HarperDB, and how does that come into the picture?
That's an excellent question. NATS is the message queue that we use to move data between HarperDB nodes. So prior to 4.0, we used technology called Socket Cluster, which was WebSockets. NATS is more akin to an enterprise message broker like a Kafka. Effectively, it has a lot more control, a lot more granularity, and ultimately it is more scalable. And as we built bigger and bigger networks, we realized we wanted to have a more bulletproof solution for extremely high volume data replication between nodes, and NATS was really sort of the game-changing technology in that regard. And more often we are seeing use cases where people are very familiar with message queues, but they need to be able to access the data within them in some sort of logical traditional fashion. And guess what? Like SQL and databases have been searching and retrieving data for forever. And so we really feel like NATS as a queue and HarperDB as the query engine and database for persistence and recording and ingest for a global network is a perfect solution.
Awesome. Yeah, thank you. And then I have a question for Michael for Ametnes. And one of the things we kind of covered on it slightly that kind of covers this question, but I figured I'd pose it to you anyways. But so can I use Ametnes in conjunction with other platforms if I already manage some of my services in a different way? So if I use a different service already for some of them, maybe like Docker and things like that, can I use Ametnes in conjunction with those other services in the same setup, or how does it work exactly?
So yeah, Ametnes is basically building on top of the constructs that we already have, the setup that we already have. It's designed to integrate very well with your cloud provider, for example. I give an example. So for example, if you chose to deploy Ametnes, but you want your backups to be written to an S3 bucket in your AWS account, it's really easy to set that up. Right. If you want us to orchestrate all the backups for you, that is really straightforward. Ametnes can be deployed in the same Kubernetes cluster as you run your other applications as well. So and furthermore, when you deploy Ametnes, what we don't vendor lock you in. So everything is transparent, nothing is locked out. We use the native Kubernetes API to deploy your services. If you then decide you want to back out to stop using Ametnes, it's really as easy as uninstalling the agent, and that's it. You'll have your services still running as normal. The only thing obviously you'll miss out is the management aspect, but then we don't tie you onto anything. So it integrates well. We've tested Ametnes on Google Cloud, Azure, on-prem, and in AWS, and it works quite well there.
Okay. Yeah. Awesome. Yeah. I know we used it in Google Cloud today, for example, for our demo. Yeah. So it worked out pretty well, and it's pretty quick too. So that's always nice. So I would like to go ahead and wrap everything up since we only have about a minute left here. So thank you for everybody for participating in the Q&A session, and thank you, Jackson and Michael, for answering those questions for us. So to kind of wrap up with everything that we've covered today, we used Ametnes Cloud to launch a HarperDB instance. Then we used HarperDB Studio to kind of go through the instance and do some querying, load some data. And then we took a look at some of the roles and all of the different charts that we can also create as well. So one of the big things that we're going to be covering next in the next webinar are custom functions. And that's where we can actually add a lot of that API functionality into HarperDB and really lower the latency a lot, since everything's embedded in one package. And it's all in just one tiny little place, right? So it's awesome. So I'm really looking forward to the next webinar, because we're going to be doing the same exact thing. We'll be doing a really kind of broad look at custom functions, and then we'll actually write some code live and look at some different use cases and some different techniques that you can do for deploying the custom functions to your HarperDB nodes. So anyways, that's going to be it for today. I want to thank everybody for attending. Thank you, Michael, and thank you, Jackson, for hosting along with me and all of your input along the way. Hopefully everybody has enjoyed. If you did miss any part, don't forget we do have the recording, so you can always catch anything that you may have missed that way. So that's it, and thank you.
Thank you.
Thank you very much.
Thanks very
All
much.
right. Bye.